What's up, scholars? Let's talk a little bit about the word congruent. So I went to my good friend the Goobs and asked, define congruent. It says it's an adjective, which means it's describing a noun. It can mean in agreement or harmony. I kind of like that. An example sentence. The rules may not be congruent with the requirements of the law. And in geometry, we have a special definition for it. Congruent relating to figures are identical in form, coinciding exactly when superimposed. Which means if you have two triangles that are congruent, they are exactly the same in every way. And there's some part of this triangle that matches up with some part of this triangle when I superimpose them or put one on top of the other. Whoa! See? Oh. There we go. Everybody's matching up. Now, it didn't matter if this one was originally upside down or if they were both flipped. At some point, there's some way, always, for me to take one and put it on top of the other, and they'll be exactly the same. Exactly the same. They're congruent. Identical in form, coinciding exactly when superimposed. Like a spaceship, kind of. Blast off! Where does this word come from? Latin, of course. Con means together, and ruere, R-U-E-R-E, means fall or rush. So you're falling or rushing together. Together. Ooh, but my hands are not congruent, so that doesn't work. From late Middle English, from the Latin congruent, agreeing, meeting together, from the verb congruere. Sounds Frenching it up a little bit. Yeah, so to fall or rush together. It's kind of beautiful. I'm into it. Alright, so we have these congruent triangles. They are identical in form. Let's draw them and give them a name, shall we? Alright, so we've got angled cat. Not angle, triangle cat. Triangle cat. And triangle dog. Let's measure everything about triangle cat. Starting with this angle C. What's your guess? I'm not going to go with a guess since I got an exact answer right here. Pretty well in the middle. 51, 2, 3, 4, 55 and a half. Nah, we can round it. 56 degrees. So we already knew these triangles were congruent. So we know one of the angles over here in the congruent triangle is also 56 degrees. Who is it? D. Nicely done. You're also 56 degrees. Don't believe me? Let's measure it. Mm. 0, 10, 20, 30, 40, 50, 1, 2, 3, 4, 5, 6 degrees, ladies and gentlemen. That is also 56 degrees. How about angle A? I'm guessing slightly over 90. Oh, manufacturers did a good job, ladies and gentlemen. They gave us actually a 90-degree angle. So angle A, 90 degrees. Look how fast that was. Get out of here. Get all the way out of here. All the way. Ah, yeah. So we know who else is going to be 90 degrees. Angle O. Also 90 degrees. And now, we don't even have to measure the third angle. We know that's 90, and that's 56. And 90 and 56 is 146. And all together, they're going to add up to 180. So 180 minus 146 is 34. But let's just double check, you know. Center. Man, it's cool when this stuff works out. Center. 0, 10, 20, 30, 1, 2, 3, 4. 34 degrees, suckers. That's right. You're also going to be 34 degrees. Because you have to be to add up to 180. Alright, well, let's check out all the sides. Am I going to move my paper or use... That's what we're going to do. Measure this one. You are 9 point... Inside the line or outside the line? Inside the line or outside the line? Calling it inside the line. 9.2 centimeters. So who else is 9.2 centimeters? Well, CT is. Cool. How about CA? So we're doing inside. The pen marks 5.2 centimeters. Who else is going to be that long? I think it's you. Oh, yeah, 5.2 centimeters. And finalmente, G-O spells go is 7.8 centimeters. So that means this one, its corresponding part, is 7.8 centimeters. You know, this is a right triangle. There's something really special that's only true for right triangles. What's only true for right triangles? That a squared plus b squared equals c squared. The Pythagorean theorem is only true for right triangles, that a squared plus b squared equals c squared. So just for funsies while we're here, like, let's test it out. Now we know c squared must be the longest side directly across from the right angle. So we're testing this, so we're saying, are they equal? Is the equality true? Wow, not degrees. Squared. Funny. And then does it matter which one we call A and B? No, you're adding them together. Okay? If I said, like, what's 3 plus 2, you'd say 5. If I'd said, what's 2 plus 3, you'd say 5. So it doesn't matter which order you add things. So let's do A is 5.2. Okay. See what we get. Punch it into our calculators. 5.2 squared. 5.2 times 5.2. That's 27.04 plus 7.8 squared. 60.84. Is this equal to 9.2 times 9.2? 84.64. I don't know. It's not looking good. 87. Ooh. That's definitely an 87. Man, what happened? I thought that was supposed to be true for every right triangle. Okay, I think this guy was the culprit. I think this should have been closer to 7.6. Human error, fellas. And Felinas. Falalos. Gotta watch out for it. If I would have measured correctly, they would have been totally equal. Promise. 100%. 100% promise. 100%. 100% promise. So now we can write a congruence statement. Because we did show that the triangles were congruent. We did show that every single part of this triangle had a corresponding part that was exactly the same in this other guy. So our congruence statement says triangle CAT, triangle cat, is congruent to triangle DOG. And all of those corresponding parts were congruent. D congruent to C. T, angle T is congruent to angle G. Angle A is congruent to angle O because all right angles are congruent. Side CA is congruent to OD. AT congruent to OG. And CT is congruent to DG. Boom shakalaka. Every corresponding part in one triangle congruent to its corresponding part. Every part in one triangle is congruent to its corresponding part in the other triangle. That's congruent, man. And it's not just triangles. You could have a rectangle and another rectangle, and as long as you could put them on top of each other, and everything lined up perfectly, they still congruent. Works for literally every type of shape. You put them together, they match up. Doesn't matter how they were oriented first at the beginning. Match up. And they're congruent. We're going to use that in the next bit.